What's up, everyone? Welcome to AP Statistics. In this video, we're going to talk about formulating questions, one of the first big ideas in all of statistics. So let's get right to it. Research questions. What do you want to know, right? There are thousands and thousands of research questions out there. What do you want to know? Now, think about you. What do you want to know? What matters to you? What do you like? What are you interested in? But imagine for a second if you own Cheez-Its, right? Cheez-Its are like the greatest thing in the world. Imagine if you own Cheez-Its. What would you want to know? Maybe you'd want to know the average size, the average number of Cheez-Its in a box, the average weight of a box. Maybe you want to know if I change the color of the boxes, could I get more sales? Or maybe you'd want to know if I add a new flavor, could I get more sales? Or which one of my flavors is the best? Or which one of my flavors is the most famous? Which one of my flavors do people like the best? What percentage, same thing. What proportion of boxes are overweight? Ooh, what proportion are underweight? These are all great questions that you might want to know if you own Cheez-Its. Now, another scenario. Imagine you're a child psychiatrist or child psychologist. What do you want to know? What proportion of kids are depressed? What proportion of kids go to bed at night hungry? What proportion of kids are happy? What's the average IQ of a child? What proportion of kids have high IQs? What proportion of kids have low IQs? Lots of different questions, right? Maybe you own an electric car company. What do you want to know? What's the top selling color of my car? What is the average amount of time that my batteries last until the cars break down? How many miles could be driven on one battery charge? If I tweak the design of the front hood, could I sell more cars? All different kinds of questions. If you own a pharmaceutical company, right? What do you want to know? Is my drug better than a different drug by some other company? What is the average number of time it takes a particular pain reliever to actually work? Lots of questions, right? You own a horse farm. What do you want to know? Is there a particular brand of horseshoes that are better, that last longer? Is there a particular surface that I should be using in the stalls of my horse mats? What's the average weight of a horse? I can sit here all day and answer questions. But again, these are all research questions. And maybe they don't matter to you, but trust me, they matter to somebody. Now, there are essentially two different types of research questions, right? One can aim to either learn about a single variable or a set of individual variables, or one could attempt to learn about the relationship between two variables. So when I talk about the relationship between two variables, I'm talking about how one variable is connected or related to another variable, where in the first type here, we're talking about a single variable, or I say set of variables. Like maybe I want to know the color, the gender, and the size of horses. Well, those are three different variables, but I don't care how they're related. I just want to learn about those three variables. Where a relationship could be something like, I want to know, does a particular type of horseshoe impact the speed of a horse? So I got two variables, the speed of a horse, another variable, the type of horseshoe, and I want to see if they're related. So again, are you looking at a single variable or the relationship between two variables? Now, while we're at it, we should probably talk about variables, right? What the heck is a variable? Because in other math classes, variables are typically letters in place of numbers. Well, that's kind of what it is here, but not entirely. But honestly, kind of, right? Okay, so a variable in statistics is a characteristic that changes from one individual to another. So you are more than welcome to use letters, just like in algebra class. For example, we can let capital E be the random variable in terms of the eye color of a human being, right? So eye color is certainly a characteristic that changes from one individual to another, and I'm going to let capital E represent that random variable. And in some people it's blue, in some people it's brown, in some people it's green, in some people it's hazel, in some people it's silver. You get the idea. But I can use the letter E to represent eye color, but it's still a characteristic that changes from one variable to another. Another characteristic could be weight. Maybe I use a capital W for weight. And I say, okay, weight is certainly something that changes from one individual to another. Somebody could weigh 155 pounds. Somebody else could weigh 156 pounds. Somebody else could weigh 200 pounds. Another person could weigh 106 pounds. You get the idea. So we could still use letters, just like in algebra class, but what they represent is not necessarily a number. Could be a number, but really it's more about a characteristic that changes from one individual to another. And we collect data on a variable from individuals. We could collect data from people, places, things, animals, whatever. We could collect data from anywhere. Now, if you were listening to me there are actually two types of variables, categorical variables and quantitative variables. And I gave the example of eye color and the example of weight, and those are exact the two different types of variables I'm talking about. And the good news is this is it. These are the only two types of variables that exist. There isn't like a third type. So let's talk about each of these very briefly because they are very simple. A categorical variable takes on values that are category, names, or group labels. So typically when I'm thinking about categorical variable, I'm thinking about words. If the answer to the question is a word, it's going to be a categorical variable. So obviously eye color, right? Blue, brown, green, hazel, silver. Those are all words. That's a categorical variable. It takes an individual and puts them into a category. So you're going to go into the blue-eyed category. You're going to go into the brown-eyed category. Other examples are, what is your dominant hand? Your right or your left? Those are words. Am I in the right category or am I in the left category? Age group. Are you young, middle-aged, or old? So if you're young, you're going to go into the young category, middle-aged. Now, I know some of you might be thinking, but wait a minute, age is a number. Yes, it is. We'll get to that in a second. But instead of, if I don't classify myself based on a number, I classify myself based on a category. I'm young because I'm under 30, then that's categorical because now the answer is a young, that's a word. Or I'm middle-aged because I'm between 30 and 50. So that, now again, that puts me into that category of being middle-aged. So that's again a word. Highest degree earned. What's the highest degree that you have earned? Have you earned a high school diploma, bachelor's degree, master's degree? So maybe I used capital D for degree, but again, the possible outcomes to that variable are words. It puts you into a category, categorical variable. So think words that describe an individual and place them into a category. Those are categorical variables. The second type of variable is a quantitative variable. A quantitative variable is one that takes on a numerical values for measured or counted quantity. So here we're talking about numbers, right? So for quantitative variables, we typically think numbers. Okay? So they're either numbers that are counted or measured. So the age of a structure, oh, that structure is 15 years old, right? It was measured 15 years. Or it's counted that it was been alive for 15 years. Oh, look at that castle. Oh my God, castle's been around for 400 years. So again, that's a number. The height of a child, that child is 18 inches tall. That child is 30 inches tall. That little baby's only 21 inches tall. Whatever. The height of a child, that's a number. You measure that, right? Salt concentration in a sample of water. Maybe you get a sample of water, you do some type of test. I don't know, some scientists can test. Oh, there are, 15 parts per million of salt in that water, whatever the heck that means, right? But it is a number and it got measured. The number of Skittles in a package, that's something you count, but guess what? It's a number. Oh, I counted 89 Skittles in that bag. I counted 15 Skittles in that small bag. Oh, I counted 38 Skittles in that medium-sized bag. Again, that's counted, but there's still numbers. So if you could measure it, if you could count it, and you get a number, that's going to be quantitative. And the other big thing with quantitative variables is it needs to make sense to get an average. The average age of those buildings is 17 years old. The average height of those children is 42 inches. The average amount of salt in the water is 15.6. The average number of Skittles in a package was 39.4. It needs to make sense to get an average. If it doesn't, it's probably not quantitative. Okay? All right, now let's get back to questions. So what type of variables does your question require? Right? Every question requires different variables. Is it categorical? Is it quantitative? Well, that's what you got to figure out, right? So let's go back to you own an electric car company. What do you want to know? What color of cars, it should be an of there, sorry for the typo. What color of cars should we sell? Well, color is a categorical variable, so I'm looking for a categorical variable there. How many hours does a battery last? Well, a battery could last 10 hours, 11 hours, 5 hours. I don't know. I'm not in the electric car business, but if I was, I might want to know that. But all of those are numbers that we could measure or count. So that's quantitative. How many miles can a car last on one charge? Once again, how many miles? That's going to be a number that I can measure. Oh, that car lasted 150 miles. That car lasted 200 miles. Well, that car only lasted 20 miles. Again, number, and it would make sense to average and say the average car lasts 177 miles. That is, of course, quantitative. What type of car should we sell? Sedans, sports cars, 2-door, 4-door, SUVs, trucks? Guess what? Those are all words. That's going to put you into a categorical variable. How much does each car weigh? Well, that car weighs 1,500 pounds. That car weighs 700 pounds. That car weighs 1,300 pounds. Again, those are numbers. You could measure it with a weigher or a scale. Guess what? That's going to be quantitative. So when you ask these questions, you got to consider what type of variable am I asking for. All right, now, let's go back to those ideas we talked about that, our goal is usually aimed at one variable or the relationship between two variables. So let's actually look at some questions that come from a single variable. So here we go. So what is the mean distance a car can go on one charge, right? That's just the only thing I care about is that one variable, the mean distance, and that's going to be quantitative, okay? But that's a great question there. What is the mean GPA of a high school student? Okay, well, that's a number. It doesn't have a unit, but that's okay. But it's GPA. So 4.0, 3.2, 1.9, right? That is definitely a quantitative variable. And I only care about that one thing. What's the mean GPA? What about the mean GPA of students that suffer from depression? Now, that's what we call a conditional value, but still one value, but it's conditional because to even be asked the question, you have to suffer from depression. So now we're looking at like a subgroup, right? The first question was all high school students. The second one is aimed at only looking at that subgroup. So if we only look at students that suffer from depression, what is their GPA? So again, we actually have two variables now. We have GPA, quantitative. Do you suffer from depression? That's yes or no. That's categorical. But again, we're still looking at one thing, GPA, but we just have this subcategory of, okay, so if I'm going to ask you, I need to first know, are you depressed or not? So again, that's kind of like a little wrinkle into it, but it's important that you understand that conditional wrinkle of, hey, the condition is you have to be depressed, then I'm going to ask you what your GPA is. All right, another question is, what is the mean length of time a pain reliever starts working in? So Tylenol, for example, how long does it start to work? You have some pain in your shoulder, you take Tylenol, 5 minutes for it to work, 30 minutes for it to work. Again, quantitative number. The proportion of students that have depression. Well, do you have depression is a yes or no. So that is categorical. Now, this is where a lot of kids get tricked because proportion is a percentage. So the final interpretation might be, oh, we found out that 17% of students have depression, but I know 17% is a number, but the question we're asking is categorical. All we did was we say, hey, we asked 100 kids, 17 of them said yes, 17 divided by 100 is where I got 17% from. That's awesome. 17 is a number, I know, but it doesn't change the fact that the question I asked was, do you have depression? Yes or no? That's categorical, so be careful. What proportion of people buy Cheez-Its? Same thing, right? I ask 1,000 people, 800 say they buy Cheez-Its, that's 80%. So the answer to the question is 80%, which I know is a number, but again, what was the question I was asking? Do you buy Cheez-Its? That's yes or no. That's a word. That's categorical. So be careful on questions like those. And again, the second thing we typically aim to look at is the relationship between two variables, right? Now, this time we're looking at not just one variable, but how one variable relates to a second variable. So here's some good questions that you're going to look at that. Is there a relationship between gender and depression? So here the two variables we're looking at is, what is your gender and do you have depression? So these are both categorical, male, female, yes, no. And is there a relationship? Male's more likely, female's more likely. You get the idea of what we're looking at. Is there a relationship between a person's ethnicity and preference for Cheez-Its? So a person's ethnicity is categorical. You're white, you're black, you're Latino, you're Asian, you're Hispanic. You get the idea. And is that related to your preference for Cheez-Its? I prefer Cheez-Its, or no, I don't like them very much. So, do Hispanics like Cheez-Its more? I don't know, maybe. I'm white. Do I like Cheez-Its more? Heck yeah, I like Cheez-Its, but that doesn't mean that all white people like Cheez-Its. But again, right, that's a question that maybe the people that own Cheez-Its want to answer. But again, that question is looking at the connection between two things. Is there a relationship between age category and music preference? Age category, again, is categorical variable. We're not asking for your age. We're putting you into young, middle-aged, old, elderly, really old, right? Okay. Teenagers, another one that's another age category. And music preference, that's our second variable. So, is there a relationship there? Like if you're a teenager, do you like hip-hop music more? If you're, if you're an elderly person, are you more interested into classical music? Who knows? But that's a great question that we want to answer, and we need two categorical variables there and look at how they're related. Is driving the speed limit associated with longer range of electrical car battery? So again, the range of electrical car battery is one variable, and that is going to be a distance, like how long does it last? Does it go 120 miles, 130 miles? So again, that's going to be quantitative. But driving the speed limit is actually, a lot of kids will say, oh, that's quantitative. It's a number. Well, no. Is driving the speed limit. So I'm not asking for your speed. I'm asking, are you following the speed limit? That's yes or no. So yes, I follow the speed limit. If I follow the speed limit, will my electric car last longer? Will it drive more miles? If I don't follow the speed limit, I go too fast. Is that going to make me go longer, shorter? I mean, who knows, right? This is a question that somebody might want to know. Is there an association between the number of hours a student studies and their GPA? This is an example where they're both quantitative. The number of hours somebody studies, it's definitely number-based, quantitative. GPA is certainly a number, that's quantitative. And we're looking at, if I study more, will I have a higher GPA? I mean, it makes sense, but is it true? Maybe if I study too much, I actually have a lower GPA. Who knows? Again, the point is that we're trying to find relationships between two variables and how they're connected. All right. How do we answer any of these questions, right? Now we got a good idea of the variables. We got a good idea of the different types of questions. We have a good idea if we're focusing on one variable or focusing on the relationship between two variables. But at the end of the day, I want to answer these questions. So I need to go and get some data to help me answer these questions. How do I do that? Well, there's two methods, observational study or an experiment. Boy, oh boy, these are super important to know and understand. Let's talk about an observational study first. If a question could be answered by just observing or just asking a few questions, then it's an observational study. Or an observational study will do the trick. Again, if all you want to know is a few questions and all you want to do is ask or observe, that's observational. So you can ask questions. You could give a sample survey. A sample survey is a survey that you give out where people fill in. You ask somebody a bunch of questions through a survey. That's a sample survey, pretty obvious. Maybe I'm going to measure something. I'm going to measure a bunch of fish. I got to get a ruler out. I got to get a scale out. Maybe I'm just going to watch, right? I'm just going to watch people. Did he buy Cheez-Its? Did he not buy Cheez-Its? Oh my God, I'm going to watch. Okay, these are all characteristics of an observational study. The key thing here is you cannot manipulate or make people do anything. You are just asking. You are just observing. You're having people fill out a survey. Now somebody say, well, you're making them fill out the survey. If I just say, sir, would you mind filling out this survey for me? Okay, the guy could easily say no. Again, you're not manipulating them. You're not making them buy Cheez-Its. You're just asking them, did you buy Cheez-Its? Right? You're not helping them. You're just saying, sir, will you get on the scale so I can get your weight? You're not manipulating them. You're not making them do anything. The moment you manipulate or force people to do something, sir, I need you to go on a diet for 3 weeks, then I'm going to weigh you. Whoa, 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 whoa. Now I'm making somebody go on a diet. That's not an observational survey. Now, all of these questions can be answered with an observational survey because all you got to do is observe or ask questions. What's the mean distance a car can go over one charge? Well, I could charge a bunch of cars and just send them driving. And when they come back or whenever they die, I can ask the drivers, hey, how far did you go? Oh, you went 130 miles? Oh, you went 141 miles? I didn't make them do anything. I just made them drive. They just drove, right? That's observational. What is the mean GPA of a high school student? Well, I could just ask you, hey, will you fill out this survey? You don't even have to put your name on it. Just what is your GPA? I didn't manipulate. I just observed. I asked them a question. I'm going to answer that question with that. What proportion of students vape? Now, that might be something I definitely want to keep anonymous, but I'm just going to ask, hey, do you vape or do you not vape? Just fill out the survey, yes or no. I'm going to leave the classroom, put it in the box in the front of the room, and at the end, I'm going to count up all the yeses, divide by the total. I'm going to get the proportion of people that vape. But again, I didn't manipulate anything. I just observed and asked. Is there a relationship between gender and depression? Are you a male? Are you a female? Are you depressed or not? You might want to keep that anonymous so they answer truthfully. But again, you're just asking. You're not forcing anybody to do anything. Is there a relationship between a person's ethnicity and the preference for Cheez-Its? Hey, what's your ethnicity? Do you like Cheez-Its? You're just asking. Observational study. Now, an experiment is where you do more than just ask questions. If your questions seek to see if one variable causes or impacts another variable to make it change, then it's an experiment might be needed. There are two big distinguishable characteristics of an experiment. Number one, the researcher manipulates or forces the change of one variable to see its impact of another variable. We're going to talk about some examples here, but I actually manipulate what they do, right? I want to know what pill, Tylenol or ibuprofen, works to relieve pain faster. So I'm going to give you Tylenol to use for 2 months. I'm going to give Bob ibuprofen. I'm going to give it to them. I'm going to make them take it. And then I'm going to record how long their pain lasted. That's me manipulating. That makes it an experiment. Now, the other big thing that's the difference between experiment and observational study is it's the only way a cause and effect relationship can be concluded. If you want to say, hey, causing Tylenol will cause your headache to go away faster than ibuprofen, you got to do an experiment. You cannot just observe. But be careful. Please listen to this. It's extremely important. This needs to be possible and ethical. For example, the goal of the following questions was to see if one variable impacts another, but it's impossible to force. For example, is there a relationship between gender and depression? I want to know, does gender impact depression? Does being a male make you more likely to be depressed or less likely to be depressed? But listen, I cannot make that an experiment. First off, I cannot force a gender on somebody. I cannot say, Kelly, you're going to be a boy today. Sorry, deal with it. Jim, you're going to be a girl today. Sorry. I cannot force that. And I certainly cannot force depression on somebody. That doesn't sound very ethical at all. So the only way I can answer that is by observing. What is your gender? Do you have depression? That's just a survey. That's observational. Is there a relationship between a person's ethnicity and preference for Cheez-Its? Listen, I cannot force ethnicity on somebody. I cannot make somebody be African American. I cannot make somebody be Latino. That way I can see if they buy Cheez-Its or not. It just doesn't work that way. It's not ethical, nor is it possible. Is there an association between the number of hours a student studies and their GPA? Listen, it's pretty obvious that how much you study affects your GPA. And a kid's GPA affects their college transcript, which affects where they go to school, right? It affects their future. So I can't change that. I can't manipulate that. I can't say, hey, Carl, you're going to study 1 hour tonight. Becky, you're going to study 2 hours tonight. Kelly, you're going to study for 4 hours tonight. And then I'm going to see how you guys do on your test tomorrow. That doesn't seem very ethical, does it? Now, maybe I could do it, but it's not right for me to do that. So some scenarios, it might seem like an experiment could work, but you probably shouldn't do it. So in these scenarios, all we can do is observe and ask questions, which makes an observational study. But this is the kicker. This is where I need you to listen to me. Because I'm only using an observational study, I cannot say cause and effect. I cannot say, hey, if you study 3 hours, it'll cause you to get an A. Hey, if you're an African American, you are going to buy Cheez-Its, right? I cannot use that word cause and effect if it's observational. I can only use cause and effect if it's a very well-constructed experiment. All right, so when can an experiment help us? Here's a couple great examples. Is driving the speed limit associated with longer range of electric car battery? This I can do an experiment. I could get a group of people and I could tell every one of them, please drive the speed limit. You guys are going to drive the speed limit. Do not go over the speed limit. Maybe I actually put some type of monitor on their car so I can make sure they're listening to me. And I'm going to get another group of people and I'm going to tell you, speed, go fast, go on the freeway, go fast. Now, maybe I have to do this on some type of closed track. That way, people don't get hurt or injured. Okay, I can control all of that. But I can make somebody follow the speed limit. I can make somebody go fast. And then I can collect my data at the end in terms of how long their car lasted before the battery died. What dosage of a pain reliever works to relieve pain the fastest? I could get people on 0 milligrams. I could put people on 50 milligrams. I could put people on 100 milligrams. And I could make you take this pill. That would be called a placebo if it's a pill that has no active ingredient. We'll talk more about that later. I can make you take this pill. I can make you take this pill. And, after 4 weeks, I can collect some data on how fast your pain went away. And then I can determine, hey, what pain reliever or what dosage works the best. Okay? Now, you might say, whoa, Mr. Princhak, I'm understanding everything you're saying, but you can't make me take a pill. Well, we'll talk a little bit more about that later when we deep dive into experiments. But the idea is sometimes experiments use volunteers, but once you volunteer to be a part of that experiment, then you're going to do what I tell you. All right, what material makes tires stop in the shortest distance? We got, rubber. Not how you spell rubber. We got rubber, we got synthetic rubber, maybe we have some type of titanium infused rubber, titanium, I'm not sure if I spelled that right, whatever. I don't know all the different, I'm not a car manufacturer, but I'm sure there are different materials that we can make tires out of. That's categorical, by the way. But we could have 50 cars use rubber tires, 50 cars use synthetic rubber, 50 cars use this new titanium rubber, and I can see which one's going to hit the brakes and stop the fastest and the shortest. But again, that's an experiment because I can manipulate that. I can control what cars get what. That makes it an experiment. What brand of grass fertilizer is associated with healthier grass? So maybe I have 3 different brands. I got brand A, brand B, brand C. Heck, I'll even throw brand D. And I'm going to get a plot of grass. And, a quarter of the grass gets A, a quarter gets B, a quarter gets fertilizer C, a quarter gets fertilizer D. Everybody gets the same amount of water. Everybody gets the same amount of sunlight. Everybody doesn't get trampled with people walking on it. It's going to be roped off and closed off. And then I can see, which fertilizer produces the best grass. But I have a lot of control there, right? I have a lot of manipulation going on there. That makes it an experiment. So if you could manipulate, if you could change one of the variables for this people, for those people, and then record what happens at the end, that's an experiment, okay? And through that, we could do... cause and effect. We can control, we could possibly say, hey, does fertilizer A truly cause healthier grass? All right, one last question to kind of look at here. Does doing yoga help reduce blood pressure in patients with a history of high blood pressure? So a lot going on in this problem. So first off, yoga is categorical. Do you do yoga? Do you not? Right? That's a yes, that's a no. Okay? Reduce blood pressure. So that's the variable I'm looking at. Now, blood pressure is definitely quantitative. They can measure that. They have tools that they can measure your blood pressure, right? It happens at the doctor's office every day. Now, notice that I only care about patients with a history of high blood pressure. So if you don't have high blood pressure, then I probably don't want you to be involved in my experiment. Now, could I do an observational study? Sure, I could do an observational study. I could go to a yoga class. And I could say, I see all you guys are doing yoga. Do you mind if I take your blood pressure? Thank you very much. And then maybe I go to a restaurant where nobody's doing yoga. They're all just sitting around eating. I say, can I take your blood pressure? Okay, great. I could then say, oh, the people who are doing yoga have a lower blood pressure, or they have a higher blood pressure, or whatever the results. That would be observational. But listen, because all I did was observe and measure, I cannot say that doing yoga will cause your blood pressure to go down. Because there's way too many contributing factors there. There's way too many confounding variables, other things that are going on at play, right? If you do yoga, you're probably healthier because you like to be healthy, you like to do yoga. That's why you have a lower blood pressure. If I go to that restaurant, people are eating out of the restaurant, they're all overweight, obese, yeah, they're going to have high blood pressure. So there's too many confounding variables there. So that's the problem that we sometimes run into with observational studies. But could I make this an experiment? Yeah, sure I could. I could get a group of 100 volunteers, people that are willing to help, all that have a history of high blood pressure. Because remember, if I go to that restaurant, maybe nobody has a history of high blood pressure. Then what the heck am I even doing? So I could certainly get a group of 100 volunteers, and I could say, all right, 50 of you guys are going to go and do yoga every day for a week. 50 of you are just going to go about your lives for every day for a week, right? And then after that 1 week, I'm going to measure everybody's blood pressure, and I could compare the people that did yoga to the people that did not, right? I made them do yoga. I made them not do yoga. Now, I certainly still have some confounding variables, but because it's not an experiment where I manipulated, I made you do the yoga or I made you not, I'm going to have a much better chance of getting accurate results. And I could maybe say, yeah, doing yoga will cause you to have a lower blood pressure. So again, a lot of these questions could be done with observational or an experiment. But listen, you have to make the right choice. You have to make the ethical choice and the possible choice. But I want to say one more thing. If you only care about a single variable, then an experiment's an out, right? An experiment is meant to look at one variable impacting another. So if all you want to know is, hey, what proportion of kids vape? Or what's your favorite ice cream? Well, you don't need an experiment to figure out what somebody's favorite ice cream is. You just ask them. That's observational. The only time we even could consider an experiment is if we're trying to figure out, does one variable have a relationship or an impactfulness with another variable? All right, guys, that's it for formulating questions. Start thinking right now in your minds, what are some questions that you may be interested in getting answered? And that's what we're going to start working on in class.